Then we have enlarging coupling, this one. This enlarging coupling will go into that T. So the enlarging coupling is 2 feet or 0.6 meters. Then I have a T, line T, 0.91. Then I have 10 meter pipe. I will repeat it on that diagram. Here. It depends how many elbows you count. Here you have 1, 2, 3, you can reduce it, finish. I have 3 elbows, I have 6 elbows there. Each elbow is 1.18, so you can multiply it by 3 now, and you get less than that. Then, this is here to go into the other T that is coming from this one. You see this one? Joining that, so it's joining as a T. That T is a line T. Is a line T, so I have to increase it from 20 kilowatts to 40 kilowatts pipe. I have a short one here, just like half a meter here. So from 20 kilowatts to 40 kilowatts. So enlarging coupling, then we go to the T. This T is larger than that. So this T is the one which is larger than that. It's the 3 1/8 inch. So the pipe, I put it 10 meters. You can reduce it now. Anyways, 10 meters here. You cannot reduce it. So I have 10 meters now. The total length, if you reduce this to 3.5, then that will be reduced. So as it is now, is 18 meters and 59 centimeters. This is for 2 1/8 inch. How do we know it's 2 1/8 inch? For 2 1/8 inch, my pressure drop is 0.1. You multiply that, you get that much bar. Where did we get the 0.1?
From the charts.
Everyone knows how to get it?
Yeah.
Just in case if you don't know it, you go to this chart so you don't waste it. You know that we have 20 kilowatts, 30 kilowatts, 40 and 60. That's the 20. You go down from the 20 to minus 30. So 20 to minus 30, I go to the left, I cut all the lines. This line. Then I go to the condensing temperature at 40 degrees Celsius. This is my line. My velocity according to the suction line is 8 to 10. So I have to be between these two lines. Not exceeding 10, not below 8. Now, from here, I'll draw a vertical line to cut the line that is coming from the 20 kilowatts, which is which one?
Red.
This one.
Violet.
This one.
Purple.
This hand is now between 2 inch and 8 and inch and 5/8. Inch and 5/8 is too far from it.
2 inch and 8.
2 inch and 8. You cannot go above 2 inch and 8. Because if I go above 2 inch and 8, I will end up here, 2 inch and 5/8. Yeah? And I will end up, if you go down,
6 probably.
the velocity will be like,
6.
yeah, even below 6. So we chosen that one. Then I go from 20 to minus 30 again.
And the pressure drop now.
Yeah, pressure drop chart.
Minus 30.
From here, I go to the left to the 2 inch and
8.
8. I go to the 2 inch and 8, then I go down.
2.
At 40 degrees, it will be here. This is 0.1 kilopascal per each meter. 0.1 kilopascal per each meter. How many meters I have?
1859.
1859. Times that gives you 1.859 kilopascal, which is, you divide this by 100, it makes 0.01859 bar. It is too much, but I cannot make the pipe larger. There is only one way to reduce these elbows. If I reduce these elbows, I can remove 3.5 meters from here. It might reduce it to, so it depends what you are doing here. You can say this is 8 meters. You reduce the elbows. But there is no way to do it less than that drawing. I don't know how big is the rooms. You have to go from the last evaporator to the next evaporator, and very close to that you go up. That's the only way you can do. So the distance between two rooms like this, if this is a room and you have another room with evaporator, that's the size. I know the wall, there is no wall. Then roughly is the distance is about minimum 8 to 10 meters.
Yeah, consecutive 3 rooms.
So that's the pressure drop. You can remove the elbows according to your calculation. So that's the pressure drop for the 20 kilowatts. Now I do it from, I've done it already there here. So the pipe that is going here, it's 40 kilowatts now. Because what I have here, I have another 20 kilowatts joining this. This pipe is for 40 kilowatts now. Then you go for 40 kilowatts. You see here? Number 2, 40 kilowatts. I need to select the pipe first for 40 kilowatts. How do I do it? The same way.
Velocity chart.
You go to the velocity here. That's 40. You go down here. You go to the left. Then you go from 40 here.
Condensing temperature.
Condensing temperature at 40 degrees and 10 meters per second. You go up.
Two inch 5/8. The blue one. One up.
Yeah, 40. Yeah, that's 40. That's 20. That's 30. That's 40. Yeah.
2 inches 5/8.
So we are between 2 inch and 5/8 and 3 inch and 8.
It's close to 2 inches.
The 2 inch and 5/8 because it's cheaper and closer to it, so we go with the cheapest one. We try that. If it didn't work, then we change it. 2 inch and 5/8 now. You go to the pressure drop one. 2 inch and 5/8. At 40, you go down here.
Temperature. 2 inch 5/8.
You go to the left.
Yeah. It's the blue one. Blue line.
40.
Blue line.
No, black one.
Condensing evaporating temperature is -30. Yeah,
Yeah.
the blue
The
line.
black one. No, blue is the
Blue.
30.
Yeah.
40. You go down. Maybe we made a mistake, I don't know. We go here. What was the size? 2 inch and?
5/8.
If it's 2 inch and 5/8, we will end up here. Here. You go down. You go down. You go down. You end up somewhere here. It's 0.12.
1, 2.
Let's see. What did we choose? 0.12.
0.059. You made a mistake.
What is the pipe? 3 inch and 8. You see, we changed it. Yeah, because that wasn't good. We go for 3 inch and 8. The pressure drop is too high. We went for 3 inch and 8. If you go back again, the black line, we go to 3 inch and 8, and we go down. Because if it's here, it's too much.
Pressure drop.
So 3 inch and 8, 0.06, smaller below that.
5.9. 0.059.
That's 0.06, we are at 0.05 something. So if we go for 0.059 or 58, then we have enlarging coupling. We go from the small pipe, look at it, enlarging coupling is here. We go from here to enlarging coupling and we go to a T. So enlarging coupling that much, T line is that much, and we have 4 meters of pipe work. So all of these will make
6.2.
how many meters?
6.28.
6.282 meters. Total pipe length is 6.282 meters. You multiply that length by the pressure drop from the pressure drop chart, you'll get 0.37 kilopascal, which is 0.037 bar. Next, we go from here to 60 kilowatts, because we have now another 20 joining. I have 60 kilowatts. From the 60 kilowatts, it goes to one compressor. Actually, that 60 kilowatts goes straight into a T. Is that right? We said?
By the enlarging company.
It goes into a T. If you remember the drawing here, it goes to the T straight away. You cannot reduce it. I'm not reducing it here. So that one doesn't exist. It goes to the T. The reducer is here and the reducer is here. So this is going straight to a T. I have to remove that one. So that's 60 kilowatts.
So you move the enlarging coupling then.
We don't have enlarging coupler. So that should go out of this. You have a T line which is 5 feet, that much. So the total length is 6 meter 52. You have to multiply 6 meter by that number. 3 inch and 5 feet. How did we get this number? Doesn't matter this number. You make that number. It depends on your design. Everyone cannot be the same design. So whatever number here, if it's reduced to 6 point something, you multiply it by that. How do we get that? We go back again here. 60 going down to minus 30, going to the left. That's 10. 10 is meeting the top line. It's, if you go here, it's between 3 inch and 8 and 3 inch and 5/8. 3 inch and 8 to 3 inch and 5/8. The 3 inch and 8, we go 60 from here, we go here. To 3 inch and 8 is here, but it was closer to 3 inch and 5/8. If you go to 3 inch and 5/8, then there's a red line here. We are again 0.59 at this point. Back to here. $60 kilowatts, 3 inch and 5/8, 0.59. You multiply it by that 6 meter, because we remove this from it. You'll have less pressure drop here. Now after that T, so it goes to a T and branching. Yeah, it's branching based on that drawing. If we go to the drawing here, I think he took it and put it here. If you see, that's 60 kilowatts, that was the elbow, is another elbow, it goes into a T. This is 60 kilowatts from here to here. While this T is 60 kilowatts, we already calculated that. Then we have 30 kilowatts. We go to the one further away, which is this one. On here, I have to reduce it to 30 kilowatts now. That's 60, goes to 30 and 30. So reduce it, elbow, suction service valve. Reduce it, elbow, suction service valve. Section 4, reducing coupling. We need an elbow here, while the other stuff will remove from here, and we need the angle valve, and we have the pipe, which is 1 meter. All of these, according to here, is 10.925 meters. You have to add elbow here. Pressure drop is 0.808. How did we get that? We are going back to here. We have 30 kilowatts. We go down, left, the green line. From here we go up to the green line. The green line is between 2 inch and 8 and 2 inch and 5/8. 2 inch and 8 and 2 inch and 5/8. And he said that the compressor is 2 inch and 8, yeah?
No.
But our pipe is 2 inch and 5/8. Yeah, this is what you find. So this is 2 inch and 5/8. Let's see on here. If you go from 2 inch and 5/8, this is the one. 30, you go down to the left to 2 inch and 5/8. You go down to here. 0.08. 0.08. That's 0.08. Remember, that's kilopascal per meter. You multiply it by the number of meters, it gives you that much. You change that to a bar, you get that many bar. So now, you add all these pressure drops together. Delta P 1, 2, 3, 4. The 20, the 40, the 60, the 30 kilowatts. So all of them together is 0.0355 bar. I know we exceeded the 0.25 bar, but that's the only choice. We cannot reduce it. We cannot go bigger pipes. So we will have pressure drop, which is 0.3 bar. That's equivalent of 3 degrees Fahrenheit, which is 1.5 degrees Celsius of saturation temperature. That's the best we can do. Thank you.
Unless
Yes.
we remove 2 alcohols.
Well, for hot gas, how do we calculate the size?
What do you mean hot gas?
Hot gas.